All right, let's look at some other convergence tests. One of the other really common convergence tests, and by the way, this is one that really can make a big difference for people who get easily bamboozled by series problems. This tends to be one of the ones that if people aren't checking for can cause some big problems. Some of the series that look like they're going to be really difficult, that people waste a bunch of time on, actually come back to what's called the Nth Term Test. Okay, the Nth Term Test, and I think you'll have a more formal definition on the sheet that I gave you, but the Nth Term Test says something that I think really should be very common sense, and that is if the terms don't decrease to zero as you go out to infinity, then the series can't have any kind of sum. It can't be convergent. Okay, so you have to be really careful. The Nth Term Test is only a test for divergence. Okay, it just basically says if the individual terms aren't approaching zero, then the series is going to be divergent. Okay, because you'd be adding some consistent value on infinitely, and of course you're not going to have any kind of sum being approached. Okay, the challenge here is people who aren't very good at series have a tendency to go, oh look, the individual terms are approaching zero, this series is going to be convergent. And yeah, that works for geometric series. Unfortunately, it doesn't work for other series. And for example, we're going to see the harmonic in just a couple of minutes, and it doesn't work for that. And that's one of the things that I think really gives people some kind of instinctual challenges to series, because once you buy into this idea that geometric series can approach a sum, you start thinking anytime that the terms shrink to zero, it's going to approach a sum, and that's not necessarily true. So again, you can only tell if a series is divergent, okay, and once you find out that it's not divergent, you would have to do some kind of other test to verify that something does converge. So it just knocks the series out, doesn't actually tell you that a series will have a sum. Okay, so for example, this one here, if you started listing out terms, this series here is going to start out if n is equal to 1, that would be the 0 power, and then 3/5, and then 9/25, and so on. You can see that we're consistently multiplying by 3/5. The individual terms will approach 0. Okay, so at that point, by the Nth Term Test, you could say, hey, this is not necessarily going to be divergent because the individual terms drop to 0. Okay, then you would switch over and you would say, hey, this is a geometric series. Because I've identified it as a geometric series with an R value that's less than 1, it's convergent. Okay, but again, if you're going to show convergence with the Nth Term Test, you're going to have to add another term on once you've shown that the individual terms go to 0. Okay, let's look at the second example. So what will tend to happen is you'll get some kind of series that doesn't fit any of the categories that we'll discuss, and you're racking your brains trying to figure out what can I try, what can I try. And the issue a lot of times is that people didn't try the Nth Term Test. It's really one of the first things you should try. If the individual terms aren't approaching 0, you're just done. It's divergent. Okay, so check this out. Think about what happens here. As n approaches infinity, these n squared terms get really large. They're going to totally overpower that -5 and that +1. And so if you took the limit as n approached infinity of n squared minus 5 over n squared plus 1, you would find out that that limit equals 1. And so what that tells you is whether or not the series is geometric, whether or not it follows some other kind of pattern that we haven't talked about, doesn't matter. But as you go really far out with that series is going to have terms that are getting closer and closer to 1. And if you keep adding 1 and something close to 1 and something closer to 1 and closer to 1 and closer to 1 and closer to 1, your series is just going to keep getting bigger. It's going to be divergent. Okay, so this is a divergent series right here. Okay, really, really important to watch out for that.